Hello friends, welcome to my channel Technical Arquen. Myself Arnab Kundu. Today I will discuss binary adder subtractor. Okay, so go for it. Today we will discuss on binary adder subtractor. Okay, so what is binary adder subtractor? In digital circuits, a binary adder subtractor is one which is capable of both addition and subtraction of binary numbers in one circuit itself. Okay, the operation being performed depends upon the binary value the control signal holds. Okay, so let's take an example. Let's consider two 4-bit binary numbers A and B as inputs to the digital circuit for the operation with digits. Okay, so for example, suppose we take A. Why? Because here we given A0, A1, A2, A3. So for this particular number, which is a binary number and consists 4 bits, so they are like that: A0, A1, A2, A3. We are take from right to left. Okay, same way we take another number which is also 4 bits binary number, so that's why B0, B1, B2, B3. So in that way take from right to left: B0, B1, B2 and B3. Okay, now there is a control line which is known as K according to this diagram, that holds a binary value of either 0 or 1, which determines that the operation being carried out is addition or subtraction. Okay, and when the control line K is equal to 1, the operation being performed on the 4-bit numbers, means these two, is subtraction. Okay, and when the control line K is equal 0, the operation being performed on the 4-bit binary numbers is addition. Okay, and should also remember that, give this example as 4-bit binary adder subtractor. Okay, but for an n-bit binary adder subtractor we use n number of full adder. Means here what happened, 4-bit binary adder subtractor, that's why we are using 4 full adder. Suppose 5-bit binary adder subtractor, then we should use 5 full adder. For an n-bit binary adder subtractor we use n number of full adders. Okay, now this 4-bit binary adder subtractor, what happened, each and every full adder have 3 inputs. Okay, what are that? One is C in, means carry in. One is A0, means first bit of the first binary number. Okay, and second one, it is an XOR gate form using K and B0. B0 is the second binary number's first digit. Okay, and these three, C in, A0 and B0, are the 3 inputs, and 2 outputs we know already for full adder is concerned. So what the 2 output? One is your sum, is represented by S0 for the first full adder is concerned, and another output is C0, means carry. Same way second full adder also consists 3 input, and C1 and S1 are the outputs respectively. Same case for the third full adder, and same case for the fourth full adder, and at the end same way the output is C out, is the last carry, and the last sum S3. Okay, now we take an XOR gate truth table where the inputs are B0 and K and output is B0 XOR K, and these are the truth table. Okay, when 0 0 you get 0, when 0 1 get 1, when 1 0 get 1, and when 1 1 0. Why? Because according to this diagram there is an XOR is form where one input is K and another input is B0. Okay, that's why you are just provide this truth table. Okay, now first full adder is concerned. So suppose when K is equal to 1, and what happened in that case, C in will be also 1, because if K is 1, so C in also goes as 1, so that's why K1, and C in is also 1. C in means carry. Okay, now so what happened, according to this truth table, so B0 XOR K equal to what? The output will be B0 complement. How? So K is 1, okay? So K is 1 means this is the two cases where K is 1, one that case and another is that case, okay? K is 1, both cases. Now we don't know what the value of B0, B0 either 0 or 1. So if B0 is 0, get the output 1 means complement. Same way, when B0 is 1, we get output as 0 means also complement. That's why we can find this equation from there, okay? So when K is 1, the output of the XOR will be B0 complement, okay? We already derived that equation from there, okay? And now what happened? So in that case what happened? So this will your B0 complement and this is your A0, okay? Now this is your full adder, okay? And full adder is concerned, so what happened? It will be A0 plus B0 complement plus C in, right? Because in full adder it performs addition of 2 or more bits of binary digits, okay? So what happened? So this is the equation for full adder. Now we are right here A0 plus, now what happened? In that line means if we write B0 complement plus 1 because C in is 1 here, okay? Now we can write that B0 complement plus 1 in that way, 2's complement of B0, okay? Why? Because we know negative number will be stored in 2's complement, okay? And in that case we can write this one B0, we can write A0 minus B0, okay? Means this particular B0 complement plus 1 can be written as 2's complement of B0, okay? Now 2's complement of B0 is your negative number, so that means negative number will be stored in 2's complement. That means when K is 1, this 4-bit binary adder subtractor performs the subtraction operation, okay? Means when K equal to 1, the operation being performed on the 4-bit numbers is subtraction, okay? In the same fashion, if we take K equal to 0, C in will be 0. When K equal to 0, C in will also 0. Why? Because when K 0, so C in will also go as 0, okay? So in that case what happened? In same way we can write B0 XOR K, and in that case we get B0. How? Just think about that. Now what happened? Here the two cases where K is 0, this is 0, this is 0. Now B0 may be 0, may be 1, okay? Now B0 0 and K is 0, what is the output? 0. Means whatever the B0, the output will be same. And same way, when K is 0 and B0 is 1 and output is 1, means whatever the B0, the output also the same, okay? So in that case we can write this equation B0 XOR K equal to B0, okay? Full adder performs addition of 2 or more bits of binary digits, okay? So that's why we can write in that way A0 plus now B0. Why? Because XOR output will be B0 plus your C in means carry in. So A0 will be the A0, B0 will be the B0, and now C in is 0, okay? That means this line can be written in that way, A0 plus B0. That means when the K's value is 0, it performs the binary addition, okay? I hope you have understood this topic. For more topics, keep watching my channel Technical Argwin. Thank you.